welcome back. We're going to be looking at the pink sheets again. Refer to this page whenever we're using algebra. So let's get started. The addition property of equality, which states if A is equal to B, then A plus C is equal to B plus C. Note that the left-hand side is equal to the right-hand side. If I were to add a number, let's call it C, to the left-hand side of the equal sign, well, we have A plus C equals B. But A plus C equals B is not necessarily true. That's not even equal. So what do I have to do to make this equal? Well, if I add a plus C to the left-hand side of the equal sign, then I need to add a plus C to the right-hand side of the equal sign. So I have A plus C equals B plus C. That will make the equation true and also equal. Let's use numbers. So 5 is equal to 5. The left-hand side is equal to the right-hand side. But if I were to add a plus 2 on the left-hand side of the equal sign, well, I'm going to have 7 equals 5, which is not true, not equal. So what do I need to do? Well, I gotta add 2 to the right-hand side of the equal sign, so that we have 7 equals 7, so that numbers equal each other. Now, me adding 2 on both sides of the equal sign right there was me using the addition property of equality. So the plus 2 on the left-hand side, whatever I do on one side, I have to do on the other side. So a plus 2 on the right-hand side. So again, that right there was me using the addition property of equality. Now, you probably have heard of that phrase before. Whatever you do on one side, you have to do on the other side. That's basically just algebra. So if I were to give you an example, 2x minus 3 equals 5. Well, what do I have to do in order for me to get 2x by itself? Well, I need to add both sides by 3 here. Me adding both sides by 3 here is me using the addition property of equality, adding 3 on both sides to balance the equation. The subtraction property of equality, which is basically the addition property of equality, but me subtracting. It states that if A is equal to B, then A minus C is equal to B minus C. So let's use our example of 5 equals 5. Well, if I were to subtract the left-hand side by 3, then you're going to be left with 2 equals 5. So in order for me to balance this, I need to subtract the right-hand side by 3 as well. So you're left with 2 equals 2. Me subtracting both sides by 3 here is me using the subtraction property of equality. In terms of algebra, let me go ahead and give you an example here. I have 2x plus 3 equals 5. Well, I need to get 2x by itself here, so I need to subtract both sides by 3. Me subtracting both sides by 3, again, is me using the subtraction property of equality. If A is equal to B, then A minus C is equal to B minus C. And just remember, when we're using algebra, we often use the inverse operations to solve for what we want. For instance, I have this 2x minus 3 equals 5. Here's that minus 3, and I want to get 2x by itself. Well, minus 3 or negative 3, what's the inverse operation? Well, that would be addition. For this one over here, we have a plus 3, so the opposite of positive 3 or plus 3 would be to minus 3. Now let's look at the multiplication property of equality, which states that if A is equal to B, then AC equals BC. Or in other words, A times C is equal to B times C. So we're going to use an algebra example. Suppose I give you 1/2 x equals 4. Of course, with any algebra problem, our goal is to solve for x. So what do we need to do here? So I see that we have 1/2 of x. 1/2 is essentially 1 divided by 2. Well, in order for me to get x by itself here, we got to apply the inverse operation. What is the opposite of division? Well, that would be multiplication. So what do I need to do here? I need to multiply both sides of the equation by 2. And me multiplying both sides of the equation by 2 here is called the multiplication property of equality. And by the way, 1/2 of x equals 4 can be rewritten as x over 2 equals 4. And if I want to get x by itself, I gotta use the multiplication property of equality here, which means that I need to multiply both sides of the equation by 2. The division property of equality. If a is equal to b and c is not 0, then a divided by c is equal to b divided by c. So let me go ahead and provide you an example here. I have 2x equals 6, and in order for me to get x by itself, I would have to divide both sides by 2. 2x is another way of saying 2 times x, so the opposite of multiplication would be division. So I'm dividing both sides by 2 here, and that's me applying the division property of equality. Now, the restriction where c cannot be 0, if I were to divide both sides of this equation by 0, this would be undefined. So c cannot be 0 would mean undefined. The distributive property. Suppose that you have a times the quantity b plus c, then ab plus ac. But note that we have a biconditional arrow here. So that means the statement can go the other direction as well. If ab plus ac, then you can say a times the quantity b plus c. So whenever you have a number in front of the parentheses, we often use the distributive property. So a times b plus a times c, which is what we get right over here. Now let's take a look at the other direction. If ab plus ac, then a times the quantity b plus c. So I'm going from here to there. So what do I do here? How do I go from here to there? Well, we can see that these two terms here from this expression carry an a here and an a there. So I need to do something called factoring. Which means I'm just basically taking the a out. I'm extracting the a out from each term, just like so. And then I'm going to apply the b plus c there. So that's the result whenever I'm factoring. I'm getting from here to there. Now, factoring is essentially just undoing the distributive property. It's the reverse distributive property. So we can see that this was already distributed. If I want to go back to its original form, all I need to do is factor. And one last thing I want to discuss for today is combining like terms. Combine like terms is a reason that we can use for our proofs. See you later.